reliability. Will you trust it? No?
Depends on the word. I'm talking about
The
the
product.
doctor.
No. Forget about the doctor. Remember, we already identified that, and we can't say to a doctor if he kills one in a
decisions, it's a problem. If she's going to count on him to do major decisions, and that means she will always be 20% worried, 20% wishing she's lucky, 20% not knowing what's going on.
And that's exactly what I'm looking for both of you. Those are called the what? The different factors in the situation. And that's why I want you to ask that here. Now, I wanted your response from that. Okay? Now your response in here. Are you sufficiently confident and reliable about the data that you are collecting? The fact of the matter, if you look at this, it's experiment design are combined with what? The reliability method. So the first thing that I would do, and it happens a lot, the first thing that I would do as a particular green, black, or master black belt is to go and verify the source of the actual data. Okay? Because if my mean tells me a certain thing, and my validation is telling me a certain thing, and is way off, well, somebody has to be wrong. Either I have been working for 10 years in here for the mean to be wrong, which we can't, because it's absolutely true, or that the actual data, that it tells me that the data is good, and I'm finding out in here that it is not a reliable data. So which one am I going to believe? You as the black belt, or the master black belt, who you're supposed to believe? Your mean, or you're supposed to be believing the collecting of the actual data? Well, most of the time, if the mean, I am having the actual mean for the past 10 years or so, or 3 years, and I know what my mean is, and I'm finding out the actual standard deviation, or the deviation from that mean is such a large, that means immediately, and this will be a great question on the actual test. It will be the first thing that I will look at it is I will not rely on that data, and then I will go collect the actual data in here. Okay? That's a standard in here. So when you look at the studies of the effect of different factors, look at those different factors. Remember what we said, there are in a lot of cases we are concentrating on the wrong thing. Okay? My mean tells me, the actual mean tells me one thing, but my data collection was about something else. Okay? So it could be an actual variation between the two of them. So, and that is put us into the next one, which is the experiment errors. Right? Doesn't matter how you do. You are as good as the data that you collect. You understand that, right? So when we look at this, the variation in the response variable when the factors level are maintained constant. If the variables and the constraints are constant, my mean and telling me and the variation of the data that I'm getting are pretty much constant. How do I know it's constant? I'll do the first test, the variation second test, the variation third test. Then I'll do when we are finding out that we are basically constant in this, then there must be something wrong in the actual machine. That the data collection is right, that means there's something wrong with the machine. There's something wrong with the process. And we look at it from the accuracy measurement is a degree of approximate of the experiment value in its actual values themselves. Okay, give you a big example about this, or let me ask you this about the accuracy in this case. Okay, when you are collecting the actual data, we said that collecting the data is a very, very important step, right? That's your job as a green belt, is to collect the actual, is to set the standards for collecting the actual data, and for you to collect the data and bring it in. Very nice. You're finding out, right, through the collecting of data, just like the question that I said in here, that the person who's collecting the data is asking the wrong question, or they're interpreting the data to be actually the wrong data. How confident are you from that data at this point? You're not confident. So should you continue with collecting the data? Should you stop it right away and start with a different progress? Stop. Very nice. So the accuracy of the measurement is the degree of the what? The proximity of an experimental value in what? To its actual value. So the actual value that we are collecting the data for is the one that we are after. And if the data that we're collecting is different than what is the actual value, that means the data is what? No longer valid. Okay? So, where do you fit nice, you're beautiful, we love you, you sat in here and you set the standards for collecting the data for all the people who are collecting the actual data. What is your job at this point? Do you sit at your office and you drink a cup of coffee and let them collect the data? The answer is no. The actual experiment in here, the DOE, the design of experiment, is actually, even though that it is not requiring the green belt to go and collect the data itself, one of the biggest recommendations and industry standards is for the green belt to be shadowing. The word what? Shadowing the people who are collecting the actual data, if it's being done by humans. Okay, and what was that here? We have words. Gemba. The Gemba walk. No, we're not talking about the Gemba walk. Gemba walk is going to the source to find out what is the processes. In this one, shadowing the employees in order for you to find out the what? If they are actually collecting the data as it standards. Observing. Yeah, observing. But the Gemba walk, you are actually doing the what? Doing in order for you to find the problems. You remember those balloons that we drew on the value stream map? On the value, in order for us to do this one in here, I just want to make sure that you are basically what? Asking the right question. Now, how do we eliminate all of this?
We automate it.
Automate it. Automate the process of collecting the actual data, whether it's on the internet or so on and so forth. So that means the what? That means the element of human is what? Is gone. So when you read the question, you read the same question, you read the same question and the same thing in this case. So, and also the difference between the actual value and the experimental value, the showing the accurate measurement is, okay, by subtracting in here the experiment error, you can determine the real impact of that. If you remember what did we say? We do the actual study, whatever we say that's plus or minus what? 3% errors. Okay? So if we are at the value in this case of 75% of the actual data in here with a plus or minus 3%, so we could either be what? 72% or what? Or 78% accurate. But which one is it? Okay? We really don't know until we get closer and closer to the actual data that we have in here. So that number in here, and you want that plus or minus to be what? The smallest as possible. Okay? And what are some of the variables that can determine that plus or minus 2 or 3%? Could be the type of questions, could be the time that we ask questions, it could be what is the population, what is the sample testing in here of the actual population. All of those can actually count on the plus or the minus that we have. Randomization, okay, which is basically the process of conducting any type of the trial, the experiment in a random manner. Remember, those usually are the best ones other than the one that we do what we advertise them, right? Because remember the suit that you're going to wear and the desk that you're going to play when it's what? When it's being identified. And we look at it as experimental units are assigned for the treatment throughout the random mechanism, such as the playing cards. Playing card, what is it? Okay, let me ask you this. You have how many cards in the deck? 52, right? What is the possibility in this case of getting the ace of diamond?
1 over 52.
1 over 52, correct? Okay, what do we call that?
Probability.
The probability of getting what? What is the probability of getting the ace and diamond and the king of diamond? 2 over 52, right? So therefore, in this case, what about the dice? What is the possibility of getting a 5 on the dice?
1/6.
1/6. Well, if you have 2 dice, what is the possibility of getting a 5 and a 5? 2 over 6. 2 over 6, which is 1/3.
No.
Yes. 1/6 plus 1/6 is equal to what? 2 6s. Which is equal to what? 1/3, right? Yeah, not 1/12.
Yes.
Yeah, that's okay. So the fact that enables you to calculate the variation and draw the statistical conclusion in this case. So from that particular randomization of what, guys? Samples. okay, the actual samples of the actual data that we get, enables you to calculate the variance and draw the statistical conclusion in this case. And remember, because of the fact that we didn't do, I think we mentioned it in here, is a type of randomization, a type of population can actually be divided, right? So I can divide the population for only the red within all of the actual markers and do randomization only on the actual red, or I can do randomization in general. And it helps to balance eliminate the impact of an extraneous or unknown or uncontrollable condition that it can have for the actual experiment. Because every single time that we are trying to study something and study one thing in particular, we have the emphasis to look at it in one way, we concentrate on it, we forget everything else. And that is randomization gives us the capability to stay within that. And okay, you call, let's assume that you are at the help desk, right? And I call you and tell you my PC is acting up. Well, first of all, what does that mean, acting up? That's what did we call that? We call it the voice of customer in this case. Voice of customer. So what is your job as the help desk in this case to do?
To put that in the way I can measure it.
Very good. So we're going to measure it in this situation. You say acting up, and okay, and we'll say, what does it do? You say it does this. So we have an idea of something that we can actually measure and so on. And the first question probably will come right over here. Is this the first time that it happened? Yeah. Okay? Has it ever happened before? What were you doing when this one happened? Okay? And can you what? Duplicate it. Can you duplicate it? Okay? So duplication is we're looking at the same variable under the same environment in order for us to get to the same result.
Trying to find a pattern.
That pattern, exactly. So if I do one test in the summer and one test in the winter and I get the wrong numbers because I'm working on the outside in this case, will that be called, for example, a repetition will be getting the same result because, well, I did collect 50 people and they're the same 50 people, but the actual environment is what? Could be different. If it has anything to do with the actual being in the outside. So a method of conducting two experiment trials of the same treatment combination consequently in the situation or conclusively under the same condition to identify the variation. Okay? So I'm not going to go to a second machine and try to duplicate what that particular person has done or what the error that did. I'm going to try to get it on the same machine itself, right? And then I will see if we can actually duplicate it or we can repeat it in this case. And that's an important concept because why? Because Six Sigma in definition they tell me, and we said before, do not waste your time on the things that they are insignificant to your study. Meaning, don't waste your time on all of the X's that they are not going to give you enough time that you're going to save or solve a problem. So if I can't repeat it, but I know it's major, then there's a big problem. Then I have to find out the what. I have to keep going down into the root cause in order for me to find out. So I'm going to have to implement likewise in order for us to do that. But if I know that it is not those prioritized X's that we did in the y equal to f of x, most likely I'm going to leave it alone and then go ahead and find something else that it will want. Here is the occurring time. Okay? So the fact here from the low to the high, this is, now usually we look at it from the low to the high as being what? The other method. But keep as in here, the low level and the high level of what we have. So you can see that in time, what is it doing? It is getting actually closer to the means, and it's going where? Beyond the actual mean. Okay. So if you are looking and interpreting this one in here for that type of that composite material, the coating, is that a good study for you or is it a bad study for you? What do you all think? Depends on what you look at it. If you look at it in here from Why is it from the low in here, we look at it from the actual mean of about 36 all the way to about 47 or 48, while we need it to be right over here? Well, maybe this is bad, and maybe this is good. Or maybe this is bad, and this is good, that it used to be, so with time, it's not getting bad. Or maybe, if you want to look at it depending on what the study they're doing, with time, it's actually getting stronger. So, is it possible? So what is it? Because I don't get enough information to here to determine what does it mean, but all I know that is what? We cross the threshold of the mean, from the negative perspective into the high perspective, in this case. So that's what it tells me. But if I know the scenario, maybe the scenario will give me exactly what it is. Because I can look at one graph, I can give it to you, you can interpret it one thing, and you can interpret it one thing else if you don't know.